All right. I'm going to go to the web pages and ask you a few questions. I'm going to share my Canvas web page. Can you see my Canvas web page?
Yes.
All right.
Yes, sir.
Thank you. Right here, I added the last Zoom class meeting again. I corrected the meeting to show the slide pages. You go and watch it again. Okay? I'm sorry about that. Now you have to go to quiz number 1, chapter 105, chapter 1. So we basically finished up the chapter 1. If you watch all this Zoom discussion, you should be able to follow up with the material in chapter 1. Okay. Let me go to, all right. I'm going to go to chapter 2 now and start the class describing the material on chapter 2. You guys with me now? Can you see first page of the slide?
Yes.
The chapter 2 is on atoms. We're going to talk about atomic structure. We already done classification of matter, elements, compounds. Okay, I can write on it. Okay. We already know matter is made out of elements and compounds. We're going to look into that little bit more in this chapter. We're going to talk about Dalton's atomic theory, where he came up with the description of a small particle called atom. We're going to look into structure of the atom. Atom is, how many of you know what particles are there, what subatomic particles make up an atom? That's mean the composition of, what is the composition of the atom? Have you heard of nucleus and electrons? Can you hear me? I am just checking as I go along. Can you see the picture, slide picture here, chapter 2 atoms?
Yes, sir.
Okay, that's what I want to know. The composition of the atom is going to be discussed in terms of electrons, protons, neutrons, 3 subatomic particles. We're going to look into the periodic table. You must have seen a periodic table in the high school labs or chemistry department lecture rooms. There are periodic table where all known atoms are put in a table called periodic table. We're going to see how it describes the atoms of different elements in the periodic table. Now, one of the most important thing about atom is atom has electrons that travel around outside the nucleus. This electron arrangement is important to chemistry. So we're going to look into details of electronic arrangement. Okay? Electron arrangement of elements, atoms, in atoms of elements are related to their place in the periodic table. Therefore, periodic table let you figure out how the electrons are arranged in an atom. All right. So we also going to look at periodic table and predict what atoms are, what elements have atoms, are bigger sizes. Some of them are smaller, some of them are larger. There's a periodic trend in atomic properties. We're going to look into that. So we're going to go over different topics in this chapter. We haven't started on the topics yet. I will come back and go through this again once we have gone through all the topics and summarize. Okay. Matter is anything that occupies space and has mass. We talked about that in previous meetings. Matter is made out of pure substances and mixtures. Pure substances are elements or compounds. The difference between an element and a compound is elements are made out of only one kind of atom. Compounds are made up of two different elements with two different types of atoms. The mixtures are different combination of elements plus compounds, elements plus elements, or different compounds. It's hard to write here. Compound, element, element combination. Therefore, mixtures are, as name implies, made out of combination of pure elements, pure substances, which are elements and compounds. Some of the mixtures are homogeneous because they are distributed uniformly, equally in the sample. Heterogeneous substances, matter, mixtures show non-uniform composition. There are concentration of different regions in the mixture, showing up they are not homogeneous. Element is a substance. For example, carbon and hydrogen and iron. They have identical atoms. There are 118 known elements, which is listed in the periodic table. Of these 118, 98 of them occur in the nature. Others are unstable, radioactive. That means they break up into different elements. The unstable elements are made in laboratory, in particle accelerators, high energy physics. So they are not common to chemistry. So we mainly look into stable elements, 98 of them. They have symbols, atoms of elements have symbols. They are one or two letters. For example, carbon is one letter, capital C, is a symbol of carbon. There are helium is a two-letter. Helium word is abbreviated because hydrogen already has H taken. Helium has to use another letter. Second letter is normally given in small case. Names are derived from various sources. So word name is used to get the symbol depending on the Latin name, English name, or German name. Names are assigned to important people in chemistry, geographic location, even the planets, and other mythological sources. We're going to look into this in detail. The second type of pure compound is pure substance is compound. They are made out of two or more atoms of two different elements, which has a fixed mass ratio. They always have, in a compound, the ratio of the atoms in mass or number is fixed. For example, water is H2O, two hydrogen to one oxygen atom. Formula of a compound which is given, written using atomic symbols for elements. So that will show the ratio of atoms in the compound. For example, sodium chloride, the ratio of sodium to chlorine atom is 1:1. Water, ratio of hydrogen to oxygen is 2:1. So formula of an atom gives the atomic ratio. Do you have a question? Classification of matter is based on pure substances and mixtures. Now we're going to look into mixtures. Mixtures are a combination of two or more pure substances. We talked about that. Mixtures could be elements plus elements, two different elements with another different compound, or two different compounds. So these are the combination that make up a mixture. These components could be in any mass ratio. Like in a compound, it's not fixed. Each substance has a different set of physical properties. Therefore, mixtures have properties dependent on the composition of the mixture. Since composition can be any mass ratio, the property is going to be different depending on the composition. Mixtures may be homogeneous or heterogeneous. Homogeneous means the components of the elements and compounds are mixed up thoroughly. They are homogeneous. Heterogeneous means there are concentrated regions in the mixture showing unequal distribution of large particles of elements or compounds in the mixture. The physical properties of components of mixture could be used to separate the mixture into its components. For example, sodium chloride and water is a mixture, homogeneous mixture. When you evaporate water, water goes away, then leaving the sodium chloride. So therefore, physical means can separate mixtures into components. Let's look at some of the problems here. Read the question. Nitrogen gas, N2, would be classified as a compound. Is it a true or false statement? Nitrogen is an element or compound. It says it's a compound. It cannot be a compound. You need to have two different types of atom. Nitrogen has only one type. Therefore, it is element. The answer is false. Now, looking into compounds that cannot be broken down into simpler substances. A compound cannot be broken down into simpler substances. Compound can be broken down into, for example, water is a compound. Sodium chloride is a compound. They always chemically could be broken down into, not physically, chemically, into hydrogen and oxygen, or sodium and chlorine. Therefore, this is a false statement. Now we're going to look at a question they ask about mixtures. Which of the following statements describe a mixture? The component elements of a mixture can be present in any mass ratio. We said that mixture don't have fixed mass ratio, any mass ratio. That's the true statement. This is probably the correct answer. Chemical techniques are required to separate the components of a mixture. We already talked about it. Mixtures are separated by physical properties like distillation, evaporation, filtration, physical. This is false statement. The component elements of a mixture can be present in any mass ratio. That's true. But the second part is chemical techniques are required to separate the components of a mixture. Chemical are not doing the separation of, it's physical. Therefore, second half of the statement is false. True and a false combined by an statement become a false statement. Therefore, C is not the answer. D, both statements are false. Component of mixture cannot be separated, can be present in any mass ratio, cannot be, that's wrong. And chemical techniques are not required to separate the components of a mixture. That's true. Now this is a false, true plus a false statement here. True statement at the beginning. This is true statement. Cannot be. That's false. Cannot be. That's false. And chemical techniques are not required to separate the components of a mixture. That's true statement. False and a true statement become false. Therefore, only answer which is true is A. If you look at the particular solid under microscope, clearly distinguishable black and yellow regions are observed. Which type of matter is this sample? This is the homogeneous versus heterogeneous. When you can see distinct regions, bulk regions, that's a heterogeneous mixture. It's not a compound. Compound has uniform distribution. Element is also uniform distribution. They are not mixtures anyway. Therefore, this answer is heterogeneous mixture. Answer is D. Now, we describe elements, compounds, and mixtures in terms of atoms and molecules. Atoms, elements, and compounds are made out of atoms. The first theory that we came up with is Dalton's atomic theory of describing an atom. Now, these theories, atomic theory, came out of some observation about chemical reaction. Chemical reactions follow law of conservation of mass. That means matter neither be created nor destroyed. Mass before reaction and mass after reaction is same. Therefore, mass is conserved. That's called law of conservation of mass. Dalton came up with the hypothesis. Atoms are made out of indestructible particles. Any chemical reaction does not destroy the atom. Therefore, they are conserved. Only attachments in the atom, bonds are only change, not the atom. So this is the idea about atom based on law of conservation mass. For example, these two compounds reacting to give carbon dioxide and lead, they exchange the oxygen is gone into carbon monoxide, become carbon dioxide. Therefore, atoms are still there. They chain the attachment. Therefore, law of conservation mass is explained by distinct units called atom. Now, there's another law which Dalton's used to get his atomic theory, based on the idea in a compound, ratio of the masses of two different elements are constant or definite. Law of constant proportion is called this law. In a compound, has fixed proportions, 1 to 2, 2 to 3, like that. So this idea came with Joseph Proust. Dalton explained this way. If you take up 4 hydrogen grams, 36 grams of water, then they could be broken down into 4 to 32 grams of hydrogen and oxygen. Law of conservation of mass is observed. Also, the ratio is 4 to 32. Therefore, simple ratio is 2 to 16. So therefore, in water, you have 2 hydrogen atoms and 1 oxygen. This ratio is always constant. That shows existence of atoms can only explain the law of constant proportion. For example, hydrogen, we talked about 4 grams. According to this equation, 36 grams. Therefore, this is 2 to 16. Why 2 to 16? Normally, mass of the hydrogen atom is 1. Oxygen atom is 16. Therefore, in water, it's 2 to 1. There are also a chemical law that is observed in chemical reaction. When two different elements combine in whole number multiple ratio, they form two different compounds. When you form carbon and compounds of carbon and oxygen, carbon can combine with one oxygen or carbon can combine with two oxygen. You get carbon monoxide and carbon dioxide, two different compounds. When the ratio of the elements are different, you get two different compounds. So this idea is the ratio is oxygen is 1 to 2 here. Oxygen is 1 to 2. That's a multiple proportion, 1 to 2. That's the idea that explains by Dalton. There are two atoms of carbon oxygen giving carbon monoxide, and one atom of carbon with two oxygens would give carbon dioxide. The ratio is 1 to 1 here, 1 to 2. Therefore, this explains formation of different compounds by different proportions of two elements. Now we have to identify what idea is explained by the Dalton's atomic theory. The fact that chemical compounds same elements in exactly the same proportion of mass regardless of the size of the sample or source of the compound is known as same proportion, constant or definite proportion. It's not the law of multiple proportion. Law of determining proportion. We don't have a law like that. Law of definite proportion. That's the same as definite is also another word for constant proportion. So this statement in question 48 is describing law of constant proportion or definite proportion. Therefore, answer is D. When you look at two different atoms, carbon and oxygen, combined to form more than one compound, the weight ratio of the element that contain with a fixed weight of the others are in whole number ratio. That is a multiple proportion. We
I'm not
talk
gonna
about
work if they're not gonna give me no money no way. Let's see.
what is the question? Do you have a
No,
question?
sir.
Okay. Somebody got upset on me.
Somebody just got a mute back.
Oh, okay. I shouldn't be judgmental about people, but sometimes it just distracts other people. Carbon and oxygen forms two different compounds. We talked about that. Carbon monoxide and carbon dioxide. That's the law of multiple proportion. Is you look into that statement and come back and look at the question again, okay? Dalton is in this it's in the picture. He proposed or hypothesized all matter,
No, this is
elements and compounds are made out of small particles called atoms. That's what we are talking about, atomic structure. All atoms are the same element and same chemical properties. Atoms of two different elements have different chemical properties. These things are pretty obvious when you practice.
text number.
All right. Compounds are made of combination of two or more atoms.
There's one more thing, like I can't grant no red or purple.
Okay.
You could get they color like blood.
Can you mute the?
He saying blood?
Like no,
Mm-hmm.
I'm talking about I can't grant no like red or purple.
Oh, okay.
Cause
Mhm.
they'll say look like blood.
Yeah.
What is the question?
I have to listen.
Y'all mute up.
To feel none of that.
You have a problem?
See?
Can
No,
you-
someone just unmute. You can unmute. You can mute them though.
I have to get out of the slide sharing. Okay, I can. Is it Crystal Wilkins?
Yes.
Okay, who's talking? Okay, no one. Okay, problem solved. So molecules are also compounds sometimes, or elements. Some molecule is a group of more than one atom. So oxygen is O2. That's called a molecule. So we describe the idea that matter is made out of small particles called atoms and describe the chemistry.
Yes.
Now, when you look at this question, calcium carbonate is heated. We're going to look at the Dalton atomic theory and laws. Carbonate breaks up to calcium oxide plus carbon dioxide. When you break up 100 grams of calcium carbonate, it produces calcium oxide and carbon dioxide. The mass should be same. That's the idea. Mass of products are equal to mass of reactants. Reactants are carbonate. The difference in the product masses is equal to the mass of carbonate. That's not true. Mass of reactants are equal to mass of product. Sum of the product masses is less than. No. Mass of each product is equal to mass of each product is equal to mass of each product. Sum of the mass of each product. The sum of the product masses are equal to the mass of the therefore answer is D. The mass composition data for sulfur and oxygen is you and here. This is law of multiple proportion. It says that when two different compounds combine in two different ratios, sulfur here, sulfur has 2 oxygen, here sulfur has 3 oxygen. Therefore, this is the law of multiple proportion. The two different compounds is sulfur dioxide and sulfur trioxide. The answer to this question, from the data, what are the formulas of two different compounds of sulfur? Therefore, this is the answer. Answer is this one here, B. Now we're done with the basic atomic structure and how it relates to compounds and elements. The matter could be substances, could be monoatomic, diatomic, or polyatomic. Monoatomic is some substances are made out of only one kind of atom, group of one atom, or some elements are made out of diatomic. Some are made out of polyatomic. We're going to look into this. Monoatomic elements are like noble gases, which are unreactive. In the periodic table, we're going to talk about noble gases. Helium, neon, argon, krypton, xenon, radon are the last column of the periodic table. These are monoatomic. Some elements are diatomic, like hydrogen, nitrogen. They are made out of molecules. When you have more than one atom, a group of atoms are called molecules. Polyatomic means more than two. For example, ozone is another form of oxygen, which is in the stratosphere of the atmosphere, which ozone prevents UV exposure. It has only 3 oxygen atoms. Therefore, it's called polyatomic, more than 2 oxygen. P4 is also polyatomic, more than 4. It's just more than 2 is 4 phosphorus atoms. Sulfur exists as molecule with 8 sulfur atoms. Diamond is kind of has 2 different forms. One form is diamond, carbon. Carbon has 2 different forms. One is called diamond, which has infinitely connected carbon atoms in the structure, and graphite, also different form of carbon connectivity. So diamond has a large cluster of carbon atoms connected to each other. When you look at things in your day-to-day life, you begin to see now what they are in terms of atoms and molecules. If you look at the soft drink, for example, this may be Diet Dr. Pepper, which I like. It's made out of, it's a mixture, homogeneous mixture. It's made out of carbon dioxide. These are carbon dioxide. And these are water. This is sucrose. Sucrose is a sugar. So this is a homogeneous mixture of which you drink often, but we never think about it, carbon dioxide and sugar, and we never think about atomic view. But when you solve problems, you need to look at it. This pen tip has graphite, so you can write using a pen tip on the paper. Your hand here is made out of proteins. Proteins are molecules, helical molecules. That's the helix. When you come to understand structure of the tissues, you're going to understand the structure of protein in terms of amino acids. Now we're going to look at compositions of matter, which Greek philosopher thought that matter was infinitely indivisible. Zeno is the one that thought if you take a piece of matter, if you break into smaller pieces, eventually you get ultimate particle. That's the idea about Zeno. Which language is the word atom is coming from? It comes from Greek. Aristotle or Socrates came up with the idea. Matter is made out of smallest particle, indestructible, cannot be destroyed. That's atom. Answer is B. Greek philosophers came with the idea. Which of the following best compares Democritus' view of matter and current view? Now, current views are based on observations or experiments. Philosophical views are coming from belief. We don't base our theories only based on belief. We need to have experiments. Both views are based on belief only. Scientific view, and a democratic view are not. Current view is not based on belief, or there's a false statement. Both views are based on firm experimental evidence. No, Democratic view is not based on experiment, belief. That's false. The ancient view based on thought only, but the current view is based on experiment. That's the correct experiment. True statement combined by but is same as and. So this is the correct answer. Last one is both views are based on combination of thought and experimental evidence. That's not true either. Therefore, answer is C. Names of the atomic symbols of elements. Let's look at it. Symbols of elements in the periodic table are derived from 3 languages. Which of the following is not one of those languages? Normally, most names of elements came from English, German, and Latin. French names are not used much. Therefore, only one of those languages are not the one that uses French. Which of the following elements is named after continent? Arsenic, gold, Au is gold. Gold is not a continent. Au is the atomic symbol for gold. EU is Europe, Europa. That's the name of a continent. Europa, Europe, Europe. Answer is C. Which of the following elements is named after a country? Francium for France, germanium for Germany, polonium for Poland. Marie Curie is a Polish chemist. Therefore, all of these are named after a country. D is the correct answer. Which of the following elements is named after a city? Boron is not a city. Beryllium is not a city. Bismuth is not a city. What is BK stand for? Berkelium. That's where the most of the artificial unstable elements are discovered in Berkeley, California. UC Berkeley, UCLA. So country, city is D, Berkeley. Which of the elements is named after a person? Erbium is not. Francium is not a person. Osmium is not a person. Sg is Seeberg. Seeberg is the American chemist who worked for University of California, Berkeley. His name is Seeborg. Seaborg, that's a B. So answer is D. Which of the following element is named after a planet? Arsenic, europium, uranium is named for Uranus, uranium. Vanadium is not a planet. So answer is C. Which of the following is not a proper symbol for an element? Let's look at the carbon is a proper. A is the carbon. B is the calcium. Now, when you look at the C, the second letter of an element symbol had to be small case. Therefore, this is the correct answer. Not a proper symbol for an element. This is cobalt. Therefore, answer is C. So we talk about atomic symbols. We use atomic symbol to write the molecular formula. It shows the ratio of atoms. Sometimes we show in a structural formula where the bonds are shown. The structural formula is shown in ball stick models, which is close to reality. So we use those models to describe structure of atoms. This one is called a space filling model. This is the oxygen electron distribution in the oxygen atom. That's the hydrogen, two hydrogens. So we use these types of representations to show different types of structures. Atom is made out of 3 atomic subatomic particles. One of them is proton. Other one is electron. Third one is neutron. Proton has a positive charge. Electron has a negative, equal but opposite. Now the mass-wise, proton and neutron had almost same mass. But neutron mass is little higher because proton plus electron become a neutron. Therefore, there's a extra charge, extra mass coming from electron. The electron mass is very small, 10,000 times less than 1. Neutrons and protons and neutrons are found in nucleus. Electrons are found in outside. So to extract the mass of the subatomic particle or atomic particles, you use atomic mass unit. Atomic mass unit is defined as 1/12 mass of a carbon-12 isotopes. We're going to talk about this a little later. One atomic mass is very small. It's 10 to the negative 24. Therefore, atoms, subatomic particles are very small. There are 3 subatomic particles. Atomic size are in the range of 10 to the negative 10 meters. Inside the atom, where a small region where nucleus is taking up is 10 to the negative 40. That is about 10,000 times smaller than atomic size. Therefore, nucleus is a very small part of the atom. We're going to answer a few questions here. Electrons are, which of the following statement correctly describe an electron? On the scale of subatomic particles, it has a positive 1 charge. That's false. It's negative 1. On the scale of subatomic particles, it has a negative charge. It's true. On the scale of subatomic particles, it has a, this is false. Electron is not massive. That's false. These are both false. Light is correct. 1 charge is correct. Okay, this is wrong. Positive charge. So this last statement, both are correct. So therefore, answer is D. What is the approximate mass of an electron? On the table, we had this value. So it's very small. Therefore, answer is C. Which of the following statement is true of a nucleus of an atom? Nucleus occupies only a tiny fraction of the total volume of atom, and most of the mass of atom is contained. These both statements are true. Therefore, whole statement is true. The nucleus occupies a large fraction of the total volume. That's false. And the most of the mass of the is contained in the region. That's true. But the false and a true make it total is false. So you go to the C. Nucleus occupies a large fraction of, that's false. and the most of the mass of the atom is considered, that's true. Therefore, this whole statement is false. So answer we end up with is A. We're going to look into, this is the last idea I'm going to talk about. Do you guys have any question?
No, sir.
Can you sign up chat box with your name? Okay, atomic symbols and mass and atomic number. Mass of atom is depending on number of protons plus number of neutrons. Electrons are, atomic number is number of protons. So mass number is protons plus mass of protons plus number of protons plus number of neutrons. Mass number is the sum of the number of protons and neutrons in the nucleus of atom. The mass of an electron is too small compared to that of the protons and neutrons, and electrons are not counted in determining the mass number. Atomic number is the number of protons in the nucleus. Atomic number is called C. Mass number is called A. A is number of protons plus number of neutrons. C is number of protons. When you write an atomic symbol for carbon, you write carbon. Atomic number is written in the subscript. Mass number is, so when you have any element, you write down mass number here and C number here. That is for any given atom. That's how we write down atomic symbol. Normally we don't write down, when you write carbon atomic symbol, we drop mass number. But in the periodic table, we know it's 6 atomic number. Mass number is 12. So from the periodic table, we can get those. The carbon atom of this composition is related to carbon 12. Carbon 12 is this one, carbon 12. There are 2 different carbons, carbon 13, carbon 12. They are called isotopes. When an element have 2 different types of atoms with same number of protons, we decide that type of the element. But they have different protons, different neutrons. That's called isotope. There are 3 isotopes for carbon 13. Carbon 12, carbon 13, carbon. This has 6, 8. Each one is increased by 1 and 2. This has 1 more. 6 become 7. 7 become 8. Therefore, different number of protons. The isotopes of an element have same number of protons. For example, when you find elements, they are not just one kind of isotope. Most elements have 2 different isotopes, at least. for carbon. This one is radioactive. It decays in the atmosphere. For carbon, there are 2 isotopes. I'm going to finish from here. The quantity of A gives the number of protons plus sum of the protons. This is the answer. A is the mass number. Which of the following define the mass number of an atom? Number of protons in the atom, number of neutrons in the atom, total number of protons in the atom. That's the correct answer. Quantity A is the mass number, gives protons plus neutrons. When you add a C, that gives number of electrons. Number of electrons are same as number of protons in a neutral atom. Therefore, it gives total number of subatomic particles. Neutrons in the atom, A plus C gives protons in the nucleus. No. Nucleus, nucleons on the atom, all subatomic particles. That's the answer. Do you guys have a question?
No, sir.
No.
I am going to continue it from next Tuesday. Okay? You guys work on the quiz 1 and understanding the chapter 1 material. Okay?
Yes, sir.
I will see you on Tuesday. Have a great weekend. Okay? Labor Day weekend.
You too.
Yeah, thank you. Take care. Bye-bye.